Hi, and welcome to the 23rd episode of the ChessTDD series. In this episode, I'm going to take a look at some of the refactoring that I was hoping to do last time, maybe getting this path checker in use in some of the some of the piece components where I was actually calculating the set of moves. But before I do that, I was hoping to get path checker under test itself a little bit. So one of the things that you'll find in a code base is you get things going and then you start to refactor. You'll extract methods and classes. And the kind of natural thing to do is pull functionality out. And then you start to wonder, at what point do I write unit tests for this new class that I've pulled out? For me, this has sort of evolved. I used to kind of do it right away, and I used to try to break things apart as much as possible, but I've gravitated over the course of time towards favoring an approach that allows for what you might think of as integration tests, 2 or 3 classes working together in concert. I don't have a problem with that. It's sort of bringing in the school of outside-in test-driven development a little bit more, I guess, or mashing it all up, but... So I don't have a problem with the majority of the coverage in this path checker class being driven by consumers of the thing using path checker, which is board. That's okay. Those tests stay valid. And I don't really have a great use case just yet for extracting and injecting path checker into board. Maybe at some point as this application were to mature, I'd want different path checking approaches, but let's cross that bridge when we come to it and not implement things that we don't really need right now. That's called speculative generality. Is a I don't know if you call it a code smell or maybe just a software development process smell, where you start speculating a lot about what you might need later in coding for that. Might turn out that you never need it. We probably won't need it here, but hey, you never know. That might look silly later. But I'm going with that hypothesis for now. So anyway, back to what I'm doing here. What I'm saying is, as best I can recall, or I could recall, I know better now, at the time I was typing this, I thought that this would take my target square and destination square and give me everything in between. And truth be told, I thought that because I hadn't looked at the code for a while, which is kind of normally the case when I'm doing this once every week or two. So I just kind of assumed that's what was going on without really looking at or reasoning about the code. One of the things I love so much about this approach is I can form hypotheses and then test them. And so it turns out I was wrong. So I gave this test a name that I at least usually will notice and come back later and fix, because I don't know what I want to call this just yet. And what you're going to see is a technique I'll employ sometimes here, which is I don't know what to call this test, because I originally set out to confirm a hypothesis so that I could tease out non-happy path scenarios, but then I was wrong about the code. So now I want to tease out my understanding here and put a test on this while I do so. So right here I'm saying, okay, I want to say it's false. We're not including the destination. And that test passed, so we are not including the destination. But now I'm seeing the real problem here. Uh-oh, I am including... Or I should have said, I'm sorry, origin was what I was not including. Now I can see that I'm including the destination. So now I want a new hypothesis, and I want to say that I don't think we should return 8-1 in this set. And I can get rid of this original assert that isn't true. So now I've got a failing test case that I want to go and make pass. I want to say, why am I returning the eventual destination? That's not path, that's destination. So as I'm conceiving of it while writing this, I'm thinking, okay, there's the origin square, there's the destination square, and there's the stuff in between. So what can I do to make this red test go green? Well, what I'm doing here is teasing out the horizontal space functionality. So I'll just, make this range go up to 1 fewer thing, and that should make the test pass. Unfortunately, what I see now is that this path checker isn't operating in a vacuum, which makes sense because I've extracted it. So there are actually cases here that are depending on the functionality of path checker where it includes that destination square in the path. So I'm kind of looking at this and thinking to myself, yikes, this functionality is breaking. the rook in the initial positioning on the board is allowed to move onto a square containing a pawn. That doesn't make any sense. So I kind of made a decision right here, and I said, rather than kind of changing a lot of prior assumptions and things that I've coded, maybe the thing to do here is to change the name of that method in path checker. Maybe I'll just live with this functionality and say, okay, it was the principle of least surprise violating to me that path checker would actually give you something called, or give you the destination in this get path construct. So perhaps, oh, and what you see, that message that keeps coming up, I've been writing a lot of Java lately, so I keep hitting F3 instead of F12 to go to definition, and yeah, that's kind of a bummer that now I'm getting things confused. So I don't know what F3 does in Visual Studio. It's not something I use, but sorry about that. So anyway, what I got to eventually here is what you're seeing is me kind of flail around and investigate a little, wrap my head around what I actually want to do here. And the decision I come to is, hey, let's rename the path checker method to make it clear that from an origin, I don't want the origin, but I'm going to get all the stops up to and including the destination. And that's a perfectly valid thing to do. As long as it's clear to clients of this API what you're getting, there's nothing, intrinsically wrong, but get spaces along path. That doesn't really sound like I'm going to get the destination. So let me give it a name where I am going to sort of be clear what's happening. So what I'm going to do is I'm going to rename this test, and I'm going to say that this should return 7 spaces. I think I renamed this later, but the idea here is I'm going to go back to making this a test that fails now with the new thing that I introduced in order to back it out. So I need a count in there, and then this is going to go red. And what I think is that I'm going to wind up with a test now that I want to keep, and then I'm going to put everything back to green when I go back and undo my change. But before I do that, I'm going to give this a name. Get spaces to destination, I think is what I called it. So the destination being included in there, at least, in retrospect, I don't know if that's the greatest name. Oh, yeah, I think I thought better of it even there. I don't know if this is great either. It's one of the nice things about having a pair partner is somebody to come along and say, that's actually a pretty stupid name, Eric. Why don't you call it this? And then I say, yeah, good idea. So anybody with a better suggestion for the name of this method, by all means, throw it in there. Into the comments, I should say. So I am trying to be communicative that get path is going to give you all the spaces along the path and the destination. So now I have a passing test, and all my tests are passing, and I'm going back to do some housekeeping to rename this what I want it to be called and get rid of the squiggles and everything. So now that I have this, I can finally, after this diversion, get to do what I set out to do, which is I'm going to say, what happens with this path checker if I give it, say the moves of a knight. If I give it two coordinates that are neither horizontal nor vertical from one another, nor are they diagonal from one another, if they're just unrelated to one another, I guess I don't know what the term for that would be exactly, but I write a test case. And what, excuse me. And what I wind up with here is, I believe what it does, what I'm hypothesizing it'll do is get into that else case that was in there, which I think is diagonal. And so it'll create some weird thing of diagonal moves when what it should really be doing, I think, I could throw an exception, but I don't know. That seems a little harsh. If I pass two sort of disjoint squares and I say, get me the path, give me the spaces along this path. Maybe that's what I should call it, get spaces along path. I don't. What it seems to me like should happen that would conform to the principle of least surprise is that I would get back an empty collection. There is no path. Can't do it, and I'll represent that with empty collection. So I'm writing a test to that effect. And as I had kind of looked at the last test and was writing this new one, it seemed a little clearer to me to say origin and destination, to have those like explicitly enumerated. Don't remember if I refactored the first test to do that or not. But so this is predictably failing. It's returning stuff. So I'm going to go into this class under test and see if I can get this one to go green. And I think that that can be accomplished by getting a little more stringent in this third condition. So I want to say otherwise, so is it on the same horizontal path? No. Is it on the same vertical path? No. Is it on the same diagonal path? No. Then I want to return empty. Might be that there's a refactoring opportunity here later, but at least to begin with, this is kind of the thing that I want to drive at. And I believe I spent a minute contemplating how to do this because I don't think there's an origin is same vertical path. So I knew that was something I was going to have to write. Oh, and I should have mentioned too that I wound up renaming the context in that test class to be a little less specific. I think strictly speaking, if I were going to follow this pattern I'd been following, maybe those should each be in their own classes, but I only saw there being one test in each, so I thought, you know, hey, a board with, or I should say a path checker with 2 spaces is maybe enough context for now. I try to be pragmatic about things. So what I'm doing here to get this test to pass is maybe a little bit of a no-no, but I think it's probably all right, given the structuring of this. The simplest thing I could do to make this pass, I'm not necessarily convinced, is to inline all this logic, since I've already got a path here for it. So what I'm going to do is make this test pass by defining a method on this struct. And this struct I don't think has its own tests either. That might be something I later want to come back and do, because usually if you're extracting, you're serving another master here the way I'm doing this method. I'm going to write into this method the algorithm that makes the exterior test pass, but what I'm maybe not going to do is account for what might happen if I pass nonsense to this method. That's the kind of thing that I'm talking about when I talk about non-happy path testing. So if board coordinate were a class, for instance, what I'm not accounting here is, okay, or not accounting for is I'm going to say, let's do some things with x and other.x, but what I'm not testing here, because it's not relevant to me at the moment, is what happens if I pass null into this method. Now, obviously, I can't do that because it's a struct, but that's something that you think about. And to me, if you're curious as to when I might go back and actually add tests to this particular type, which doesn't really have any that just exercise it, it's to drive out things like that as a common one. So what happens if I pass null? What happens if I pass garbage? What happens if I pass things other than on the usage path of this class I'm extracting functionality from? That becomes a pretty good way to a pretty good heuristic for when you might want to give a type its own tests. So you can see me floundering a little bit here, but the algorithm isn't terribly complicated. I'm going to see if the distance between x is equal, the distance between the two x's is equal to the distance between the two y's, and that's my absolute value. My hypothesis now is that will catch me correctly when I should be going diagonal. And now if I return the empty collection, this is going to be behaving the way I want it to. So there we go. And now I feel pretty good about this because this path checker class has a lot of clients coming through board. So I've got all this functionality where I've lined up pawns and spaces without pawns and all that. And I feel good. I'm building up a pretty decent test suite here. So pretty sure if I were doing something dramatically wrong, these tests would now be barking at me. And it's not that in and of itself, you can get a false confidence from your test suite. It's important to reason about your code. But those two things, so I looked at that method that I just wrote, is on same diagonal path, and I feel pretty good about my reasoning there. And that, with sort of the double entry check of the tests all passing, makes me feel really good that this is, that I'm coding deliberately. So scientific method sort of thing, form hypothesis and then verify them. Now, I was looking at this class and contemplating, are there other things that I might want to check? Are there some sanity checks that I might want to do on these coordinates coming in? I think not for the moment, and it was getting a little long into the video here without really having accomplished terribly much. But I guess it's always possible I could check to see if the coordinates passed in had negative values or something, but I think checks like that might exist on board coordinate itself. There was nothing particularly obvious or compelling to me that I think I ought to be doing there. So I moved on and I started looking at rook because I think vertical might be the simplest way to see if I could use path checker here. And what I discovered is I had forgotten exactly what this algorithm looked like, so I'm actually just going out to board size and enumerating all of the different places that I could go in terms of X and Y. And so I'm not off the top convinced that path checker winds up gaining me anything here, because what I would have to do is essentially use path checker with my starting location as passed to this method, and then I'd kind of have to go and compute the logical ending locations anyway. That might be a bit of a win, but it's not an automatic win. I was thinking maybe off the top I could just have a one-liner in there with path checker or something, but that doesn't look to be the case. I would still need to go in and get kind of the difference between where I'm starting from and figure out where the edge of the board is, and then get that path and then union it with the path to the other side of the board horizontally, and then the one side vertically and the other side vertically. So I would actually be getting 4 different paths and then kind of slamming them all together. So that doesn't necessarily seem great. It might be a card for another distant refactoring here to say, can I look at what I'm doing with the pieces and then look at what I'm doing at the board and merge so that path checker, or now path maker, as I thought it was a better fit name-wise, could I kind of merge those things together? We'll see. So I moved that into in progress after the fact, too late. Same goes with this guy here. I've looked for this opportunity. Maybe I didn't look hard enough, so I figure I'll leave it over there as a placeholder for what I was just talking about. Like maybe if we actually modify, tweak it a bit, they can use the common logic. So now to close out, I thought that what I'd do is test my hypothesis. I sort of mentioned it in passing a while ago, and it was probably confusing what I was talking about. When I was figuring out this path checker situation, I mentioned that, oh, well, because we're only handling horizontal, vertical, and diagonal, we're kind of by default handling the knight case and the weirdness of the knight being able to hop over pieces. So I thought, hey, let's go back to board and see what happens if I get the moves for the knight. So like, for instance, on this board paradigm where I have the row of pieces and then the row of pawns set up, bishop and rook, they can't move. But because path checker isn't looking for blocked in oblique moves like the knight's move, I have this suspicion that what I'll get back is that it's true, that when I move this knight starting at 2-1 to the 3-3 section, or the 3-3 coordinate, it'll actually let me do that. And that's good. I've sort of, for free with all this mucking around I've done with the path checker, the way I've handled this has resulted in getting some of the knight's moves for free. So for the sake of thoroughness, I'm going to tease out another condition here, and I just want to make sure. And I do a lot of experimenting in tests. This is sort of outside of the realm of TDD because I'm not writing a failing test with the idea that I want to change something in production. I'm running an experiment. I'm saying, I'm 95% sure that what I'm about to do here is going to pass. And it should pass, so there's no harm in having this test in here. So I'm just going to write it and use this opportunity to prove a hypothesis and to add a valid test in. You want to be careful with this. You don't want to get into the trap of writing sort of spurious tests to confirm your understanding, or writing tests that are kind of degenerative, that are so simple they don't mean anything. But, I don't think this falls into that category. I have a chessboard fully set up for the first move, and it's a perfectly valid test that the knight should be able to move to that 3-3 square. If it's not, if it can't make that move, there's something wrong. So I don't mind having these tests in here. And in fact, these are the kind of tests that I might come when the whole thing is, in my mind, kind of proved out. These become your sort of integration tests, or tests where you're not doing TDD anymore, where you're actually getting a little more rigorous with what you're checking on the system. So, you know, if you can get them in here anyway, hey, great. So now I'm going to say that I've got this particular coordinate here in my knight moves. Any Bob Seger fans out there might get a kick out of my naming. And now for the most interesting part, and it was getting really far into the video, so I kind of stopped and left off with one kind of final piece of narration, or one kind of final piece of logic, and something that in my narration I'll touch on. Oh, right. Do it once, do it twice, and endure the duplication. If you're going to do it a third time, maybe make it a little better. So the knight on the white side of the board, which conventionally I'm going to say is the part that's closest to us in terms of the coordinates. By convention, I'm just going to give this a name and say that we have this set of moves for the left white knight. So I don't have to keep instantiating, or I should say keep getting the moves from the target. I can just have this one-liner. Reads pretty well. Assert that the moves for the left white knight has 3-3 in it. Sounds good to me. I'll do that once again for this existing test, and now to prove the concept, when I write the third test, my life gets a lot easier. And what I was going to say is, as I'm writing this third test, I started to have this thought, like, I don't think that this test is going to pass, but I'm going to write it anyway. See, I started to hesitate right there. What I want to say is there should only be 2 moves. I just know this from playing chess. When the board is pristine, so to speak, there's only 2 moves for the knight. One of the moves that he might have would take you off the board to the left, and the other one would put him on the pawn in front of your king, I believe. So, But then again, I looked at the time as I was recording this, and so we're getting to that 20-plus minute range. So made an interesting discovery here, which is that we're going to have some work to do, because it's returning a move for knight where there's a piece of my own there. So that's something that's got to get fixed. And maybe we'll delve into the whole concept of capture versus friendly pieces. It's a pretty big piece of functionality, and you know, maybe next time's the time I want to talk to it. Who knows how I'll feel in a week or 2 when I'm writing this next time, but or recording this next time. But that is when I will see you. So thanks for watching, and I will catch up with you again the next time I'm on. Oh, I forgot to mention the most important part of this lesson to take away. I'm deleting this test. I got the card in there. I do not want to leave a failing test. That's bad mojo. So that's one last lesson to take away. And now this time for real, I will see you next time.